So we've just finished this whole lecture about things changing, life changing. But what's happening to our Earth? Can it change? Can it go through changes like life? So this is a coral reef, and this is a time-lapse video of the coral. And let's see what happens in this coral reef over time. Look for the color changes. Look for, wow, what happened to the coral? Here it is before. Here it is today. What's missing? This diver's swimming through the ocean. Let's see if you can count the number of jellyfish that you can find swimming around him. I counted 6. And this is just in the ocean. And this is plastic in the ocean. It's a manta ray. That's not plants at the surface. That's a layer of plastic. So, did you see 6 jellyfish, or was it really hard to see the difference between the plastic and the jellyfish? This is a whale that has beached up on the beaches of Indonesia. And this is what they're taking out of the stomach of the whale. Could something be going on around the Earth? I wonder who the first is, if that's the second.
Was when an American about to go abroad would be warned by his friends or the guidebooks not to drink the water. But times have changed, and now a foreigner coming to this country might be offered the following advice. If you visit American City, you will find it very pretty. Just 2 things of which you must beware. Don't drink the water and don't breathe the air. Pollution, pollution, they got smog and sewage and mud. Turn on your tap and get hot and cold running crud. See the halibuts and the sturgeons being wiped out by detergents. Fish gotta swim and birds gotta fly, but they don't last long if they try. Pollution, pollution, you can use the latest toothpaste and then rinse your mouth with industrial waste. Just go out for a breath of air, and you'll be ready for Medicare. The city streets are really quite a thrill. If the hoods don't get you, the monoxide will. Pollution, pollution, wear a gas mask and a veil. Then you can breathe, long as you don't inhale. Lots of things there that you can drink, but stay away from the kitchen sink. The breakfast garbage that you throw into the bay, they drink at lunch in San Jose. So go to the city, see the crazy people there, like lambs to the slaughter. They're drinking the water and breathing the air.
Thank you. This is Big Idea 3. Earth is a complex system of interacting rock, water, air, and life. The four major systems of Earth are the geosphere, hydrosphere, atmosphere, and biosphere. Earth's geosphere is made up of its metallic core, solid rock, and also molten rock, soil, and sediments. The atmosphere is the mixture of gases surrounding Earth. The hydrosphere includes water in all its forms: ice, water vapor, and liquid water in the atmosphere, in oceans, lakes, rivers and streams, water in soils, and groundwater. The biosphere comprises Earth's living things, which can be found in many parts of the geosphere, the hydrosphere, and the atmosphere. Humans are part of the biosphere. Human activities can have important impact on all four spheres. All Earth processes are the result of energy flowing and mass cycling within and between Earth's systems. Earth's energy comes from the Sun.
So let's start our study in the biosphere, and we're going to see how human influences affect the biosphere. And one of the things that humans produce is pollutions. And you've heard of water pollution or air pollution or soil or agricultural pollution or runoff. So what we want to investigate is, how do the pollutants enter into the biosphere? And so I want to show you two different ways that can. The first is sewage. This is what you flush down your toilet. I know many of you don't think about where it goes, but sewage is a big problem here. Every day in Los Angeles, 275 million gallons of toilet flushing flows into Hyperion, which is a water treatment plant near the coast of Los Angeles. And so hospitals, commercial, industrial, and residents, every time they flush, every time they drop something down the sink, every time they use the washing machine, anything of those kind of chemicals, anything in the toilets, all go to this treatment center where they're processed. And then eventually it's sent into the oceans right off Santa Monica Bay, about 5 miles off the coast. Another place that we tend to see a lot of pollution enter into our water is something called a landfill or a garbage dump. So everything you throw away, sometimes people throw away hazardous plastics or metals or computers or anything that's toxic, can be buried into the soil. That's a landfill. And then it trickles into the water table and then can move into the oceans. Let's see how this can enter into a food chain.
This is the story of 3 plastic bottles, empty and discarded. Their journeys are about to diverge, with outcomes that impact nothing less than the fate of the planet. But they weren't always this way. To understand where these bottles end up, we must first explore their origins. The heroes of our story were conceived in this oil refinery. The plastic in their bodies was formed by chemically bonding oil and gas molecules together to make monomers. In turn, these monomers were bonded into long polymer chains to make plastic, in the form of millions of pellets. Those were melted at manufacturing plants and reformed in molds to create the resilient material that makes up the triplets' bodies. Machines filled the bottles with sweet, bubbly liquid, and they were then wrapped, shipped, bought, opened, consumed, and unceremoniously discarded. And now here they lie, poised at the edge of the unknown. Bottle 1, like hundreds of millions of tons of his plastic brethren, ends up in a landfill. This huge dump expands each day as more trash comes in and continues to take up space. As plastics sit there being compressed amongst layers of other junk, rainwater flows through the waste and absorbs the water-soluble compounds it contains, and some of those are highly toxic. Together, they create a harmful stew called leachate, which can move into groundwater, soil, and streams, poisoning ecosystems and harming wildlife. It can take bottle 1 an agonizing 1,000 years to decompose. Bottle 2's journey is stranger, but unfortunately no happier. He floats on a trickle that reaches a stream that flows into a river, and a river that reaches the ocean. After months lost at sea, he's slowly drawn into a massive vortex where trash accumulates, a place known as the Great Pacific Garbage Patch. Here, the ocean's currents have trapped millions of pieces of plastic debris. This is one of 5 plastic-filled gyres in the world's seas, places where the pollutants turn the water into a cloudy plastic soup. Some animals, like seabirds, get entangled in the mess. They and others mistake the brightly colored plastic bits for food. Plastic makes them feel full when they're not, so they starve to death and pass the toxins from the plastic up the food chain. For example, it's eaten by lanternfish. The lanternfish are eaten by squid. The squid are eaten by tuna, and the tuna are eaten by us. And most plastics don't biodegrade, which means they're destined to break down into smaller and smaller pieces called microplastics, which might rotate in the sea eternally.
So let's examine the idea that plastics can enter into the food chain, and maybe this is a reason why that polar bear is starving to death. So we know that the plastics that make up these plastic bottles and bags, etc., do contain things that are toxic to animals. These toxins can enter into the food chain. Either they can be eaten, as we just seen in the video, and then the plastics take up the space of the stomach, tricking the animal into thinking it's full, and then they starve to death. Or, as the chemicals in the plastics break down, they enter into the water supply, as we saw also in the video, called leachate, and then that toxin enters into the water and then moves through the food chain. And we call that biomagnification, where the toxin enters into the food chain and then concentrates and gets larger every trophic level. So it's very low in the primary consumers and very high in the predators. And one of the classic examples is DDT. It was a pesticide used in the 50s and the 60s. So you can imagine the DDT would be in the water supply, would enter into the ocean. The DDT would be eaten by the plankton. And now you'll see there's 5 DDTs floating in this plankton. And then the worms that eat the plankton, now the DDT is not used for energy, so it concentrates. So there's 10 DDTs in the worms. The fish eat the worms, and now the concentration of DDT gets even higher. And we call this biomagnification. Let's go ahead and do our computer simulation where we can model the effects of these toxic plastics in a food chain in the ocean and see if we can apply that to our polar bear question.